Okay, guys, so today I want to go over memory. So when you're programming, when I first started out programming, I didn't really know what was going on under the hood, and I didn't know a lot about memory. So the last few classes that I've taken at my university, we have kind of dipped into C and C++, and I've also done like an operating systems class where they really teach you about what's going on under the hood in the memory. And it's pretty interesting, and I think it's important to know. Okay, so let's dive in. So what we're going to be talking about here is main memory. So basically where your RAM is going to be your main memory. So we're going to talk about what's happening inside here on a specific program. Now, a zoomed out approach, a higher level. So basically, you're going to have your CPU, maybe your hard drive or your hard disk, maybe a solid state drive. But usually in your main memory, you're going to have multiple programs loaded in here. And if you're on a single core or single processor system, your CPU is going to use a scheduler to basically switch back and forth between these programs. So when you have multiple programs running on your computer, they're not, running exactly at the same time because a processor can only execute, one instruction at a time. So basically what it's doing is it's context switching is the term that it's called, but it's actually switching between all those programs. Let's say if you have Microsoft Word open and a YouTube video. So those programs aren't actually running at the same time. They're just switching back and forth so fast, and the processor is executing those instructions very fast and switching back and forth. Now, a lot of these processes or threads might have higher priority. So let's say if you're in a specific program where it does have higher priority, your YouTube video might buffer or something might load a little bit slower because the other program or process has higher priority. Yeah, that's just a high level of the main memory and the RAM there. But let's zoom in and let's look at what's going on in a single program that we're coding up. Let's clean this up too. So when you're running a program, you're going to have two types of memory, okay? So one is going to be called heap. And then the other will be called stack. Now, these are also two types of data structures. Heap has nothing to do with the data structure. Stack, it does. It's a stack data structure that's inside here. That's how it works. So stack, you can think of the data structure, but heap is going to be totally different. Okay, so let's say you have your Java code up here. So this is your high-level instructions that you're typing into your editor. So let's break this down and see what happens. So when you compile this, so you're going to compile that into machine code. So eventually it's going to get turned into zeros and ones so that your computer can understand that. So we'll just write machine code. So basically zeros and ones in here, but you'll have your lines of code. So in your main memory, you're going to have a little chunk that is for your lines of code to be stored. Now, let's make this just a little bit larger because we might need a little bit more room here in the stack. I think that's okay. Okay. So let's just get an example over here. So let's just say we had a class. I'm getting lazy. We'll just put example EX. And then let's just declare int A int b. So these are going to be global variables. They're not inside the scope of a method. But let's make our main method. Now when you compile a program and run it, your the operating system or whatever's in control is going to always look for the main method. That's basically the starting point of every Java program. That's where everything is basically executed. That's basically your driver. And let's just put a method 1 over here so I can show that. Getting really lazy with the naming here. And let's just put a int c in there. Okay. So compile all of this. Now this is where it gets interesting. So when you first start out programming, you don't really understand why am I declaring these first? Why am I initializing or why am I declaring these variables? It's basically because these are going to be static. So when you compile this, these variables, there's a section actually before the stack which finds your global and static variables, and it's basically, so we'll put static global. So basically it's going to compile and it's going to set aside memory for these variables. Now in most systems an integer variable is 4 bytes. So it's going to take 4 bytes and declare and set it aside for those variables. And that's why, so when I first started programming, I didn't understand why there's a long and there's an int. And it's basically because you have to set aside how much memory you're going to need. And you want to be cautious of that. You don't want to use too much memory. So if you don't need a long is a lot more bytes of memory and can store higher or larger numbers, but you might only need an integer. So that's going to set aside 4 bytes of data for you. Okay, and it's going to get down to the main method. Now that's where the stack comes into play, and basically in a sense for every method there's going to be what's called a stack frame. So it's going to create, and a stack is last in first out, so it's going to basically, like the stack data structure, create a stack. So main method. Now and then when your main method is calling these other methods, let's say method 1, if it calls method 1, it's going to pop that onto the stack as well. Now when it's done with method 1, this memory manages itself. You don't have to worry about deleting things. It's going to say, hey, you use method 1 and we don't need it, so let's pop it off. Okay? And same thing for method 1. These are local variables inside the scope, so they're going to be inside the stack frame for main. So there's going to be an int variable here called c. Now your code right here, it can directly access your variables, okay? But when you get into reference variables, that's when the heap comes into play. So stack, that's basically going to be your methods. They're going to be what's called, I'll write it out, like I said, stack frames. It's going to be pushing those methods onto the stack, and then when you're not using it, it's going to be popping them off. Okay. Now let's get rid of these methods here. So I think we got that down. Now this is just a very high level. I just want to go over this. So let's say you had a class, and actually we need our main method back. So, and this isn't the correct syntax, obviously. I'm just trying to give a simple example here. So inside your main method, let's say you are creating a object. So ex of type ex, we're going to call it object1 equals new. EX, just call the default constructor. So what is happening is whenever you call the keyword new, that's when the heap is coming into play. And that's why these are called reference variables as well. I'm going to show you that here in a second. So when we're using the keyword new, this is when the heap is coming into play. Heap is usually going to be used for arrays and objects. Now, in arrays and for objects and things like that in Java, you don't really have to do anything different. But in like languages like C, you're going to use pointers. You'll be using the asterisk to basically create those pointers. And I'll kind of explain that here in a second, but back to the new keyword. The new keyword means that you're going to be creating memory in heap, okay? This heap is basically all the memory that you have available to use. You're in control of this, which could be pretty dangerous, okay? So you as a programmer got to be cautious, especially when you get into C and C++, because once you use memory in the heap, let's say you create an array. Actually, and I'll demonstrate it here. Let's get this guy out of here. Let's clean this up a little bit. So yeah, when you're creating this object, you're actually creating a pointer, object1. This is not, this right here, this variable, does not actually hold the object. That's why it's called a reference variable. It is actually, I'm going to put an asterisk here, even though you don't have to do that in Java. But it's actually a pointer. It's creating memory in the heap for an object, and it's pointing to it. Okay? So whenever you use the new keyword, you're basically accessing memory in the heap. And you're going to be using a pointer. So basically in your code, this variable is going to hold an address. So you're not directly accessing the memory or directly accessing the variables like you are here. These are directly going to the memory. This is a pointer. You're accessing the address and then following that pointer to where that object actually is. Now in Java, it's nice because we don't have to worry about it too much because we have what's called basically a garbage collector. Okay. In C and C++, we don't have this guy. It's a little more complex because in C, I'm going to write it down here. Let's say let's say we did something like that, and so we have a pointer. And let's do, because in C you're going to use an API or a method called malloc, which is going to, memory allocation is basically going to allocate some memory inside of the side for you. And let's just say, so we know what a garbage collector is. I'm talking about it now, but size, this is usually how you, now I know we're basically focusing on Java, but I just want to get this across. Size of int. This just helps when we're talking about memory. So in C, you'll create a pointer and you'll say, hey, set aside some memory for me. How large of a memory chunk do I want? I want it to be the size of an integer. So it's going to say, hey, an integer is 4 bytes. Go into the memory, set aside 4 bytes, and then assign it to this pointer. And that pointer can be used to store an integer. Now, let's say if we had another line of code that p equals, and we changed it to like a different pointer. Let's say this is another pointer j. It is basically going to take that pointer and point to somewhere else. Okay? Now you notice this chunk of memory is still here. That's where in Java we have the garbage collector. It's going to clean it, garbage collector. Again, I just want to make sure I write that down. Garbage collector, Java's smart enough to say, hey, they changed the pointer. They don't need this block of memory anymore, so let's get rid of it. In C++ or C, you actually have to free up that memory and delete it. You have to manage this memory, okay? Now, like I said, this can kind of give you an idea that you need to, I think it's important to have an idea what's going on in memory so you can, when you get into more complex programs, you can watch out for this stuff. You can manage your memory, you can have efficient programs, you won't run into Stack Overflow. A lot of times when you're doing recursive methods and things like that and you keep doing method calls, the stack is gonna, it has a set aside memory for you and it's gonna go beyond that bound and it's gonna cause a Stack Overflow. And when you get into creating your own memory and managing it and things like that, in C and C++, you're gonna have some issues if you don't manage it correctly. Okay. All right, guys, so I think that will be it for this video. Hopefully that helps you guys out quite a bit, understanding memory and what's going on under the hood. If you guys have any questions, leave some comments below. Thanks for watching.